Hello, my name is Dr. Budner, and I'm going to tell you about the projects that I have going on currently and that are going to carry into the summer that will be involved with the SCoRE program during 2023. First, I'm going to turn off my the projects that we have going on at this time and through the summer are going to revolve around the analysis of and production of fermented beverages. So those two beverages are specifically kombucha and beer, and we'll talk about each one of those independently and then come together at the end to talk about the analysis that we're going to do for both of those. They are both fermented beverages, so the types of analysis that we're going to do is going to be the same for both of them, but we're going to look at the reasons why we're looking at those first. And the two major projects is we're going to look at the impact of water ionic concentration on kombucha fermentation. And then for beer, we're going to look at the differences in beer brewed with a gluten-free grain, specifically millet and buckwheat, and compared that to barley. If we look at kombucha is a fermented sweet tea. So in order to make kombucha, the first thing you have to do is you have to make tea. So you make tea, you add a significant amount of sugar to it, and then you add this microbiome, which consists of both bacteria as well as yeast. And you will see it's in this fermentation process that the kombucha and the beer, differ. Here we have a very complicated microbiome, which is doing the fermentation, that contains this SCoBY, which is a symbiotic culture of bacteria and yeast. So both bacteria and yeast are undergoing this fermentation. It's also open to the atmosphere, so it's an aerobic fermentation. So we're letting the process occur with in the presence of oxygen. We're not depriving the system of oxygen, so it allowed some different flavor profiles to exist. And what we're doing is we're going to create our own kombuchas, and we're going to brew those for 14 days, and we're going to look at the fermentation products and see how that differs. If we look at why we're interested in studying kombucha, we've seen recently a large increase in the overall consumption and production in kombucha. We see kombucha now being offered at all major grocery stores and other food distribution centers. And part of that is that the Americans are just coming to understand and appreciate kombucha. But as this appreciation grows, we're seeing a larger amount of health benefits prescribed or associated with the regular consumption of kombucha. And those can range anywhere from eliminating wrinkles, combating acne, to increasing fertility, weight loss, reducing blood pressure and cholesterol, relieving arthritis, but also some more major things like purifying the gallbladder and inhibiting cancer proliferation. So there's a variety of interesting things associated with kombucha. Unfortunately, this summer we're not going to get to studying any of those, but we really want to understand the process that kombucha undergoes as it ferments and what sort of things control the final kombucha product. And we're going to start with water chemistry, in part because we know that the water chemistry in terms of the brew has a major, or can have a major, effect on these fermented beverages. And we can see that when we drink water. You'll see that you buy bottled water, a lot of times they've added additional minerals and ions to it to add and enhance the flavor. And we look at examples of beer and wine. We see that there are some types of beer, styles of beer, that have been developed specifically with specific ion concentration in mind. So if we look at a Pilsner, for example, that is a function of the water in Pilsen, the Czech Republic, which gives that a distinct profile. Unfortunately, that little is known about how this water chemistry interacts with kombucha fermentation. So that's the sort of the goal that we're looking at this year and into the summer. In that, we're going to brew kombucha with various, starting with DI water, with various concentration of ionic compounds that are listed here. And as well, so we're going to have a small, we're going to do each one individually, and then we're going to also do some composites either at the low or and high level. So all of those compounds together at the lower level above zero, and then a higher level, say the 100 or 200 milligrams per liter, and determine, we're going to be monitoring the effects of fermentation by looking at several different fermentation products, and we'll get into those at the end. This should allow us to give a sense of what is affecting fermentation both on an individual ionic level, but also some summative effects of these various ions on this kombucha fermentation. The second major project is we're going to brew beer. And the brewing of beer is sort of more complicated, but it relies on extracting fermentable sugars out of the grain material. Traditionally, that's done with barley because it has a fairly large amount of fermentable sugars that it can be extracted, but also it has the correct enzyme profile to help the conversion of the starch within the grain into simple sugars that we rely on for fermentation. We are interested, though, in brewing beer not with traditional barley, but barley from grains that do not traditionally contain gluten. And the reason we're looking at that is primarily a relationship with gluten intolerance. Gluten intolerance is one of the major food allergies or conditions in the U.S. About 1 in 133 Americans have some sort of gluten intolerance, and it is the number one or the most common food intolerance worldwide, and it has an effect on the intestines as you can as you ingest gluten. If you're gluten intolerant, you can have some either minor or fairly major effects of this gluten to cause gastrointestinal distress or just discomfort. And we're seeing that a large number of people are now either responding to this gluten intolerance or figuring out they're gluten intolerant or avoiding gluten for some other reasons. So we're seeing an increase of these gluten-free products, and the world of beer has not been unaffected by that. So we can see some fairly large producers making gluten-free beer. Most of the time they're made from sorghum. And we've done quite a bit of work to investigate the chemistry of sorghum-based beers. But there's a lot of different cultures that use a lot of different grains to ferment and to get beverages. The ones that we're going to look at this summer are going to be millet and buckwheat, which are two distinct gluten-free grains. They have sort of different properties and different sort of sizes, but they're grains that are typically used for this gluten-free beer formation. And we're going to do a comparison from the beers brewed with these two grains from traditional barley to see, again, by looking at those fermentation products, what are the differences and where do they lie. The things that we're going to monitor are things like pH, total titratable acidity, the color, the total phenols, which gives us a sense of a variety of different health things, what's called FAN or free amino nitrogen, the amount of ethanol that's produced. We would expect a fairly large amount, 4 to 5% alcohol, ethanol to be produced in the beer, but we want a much lower concentration in the kombucha. We want to track the fermentable sugars, both pre-fermentation and post-fermentation, and see how the different conditions affect those changes in fermentation, which sugars are used by the microbiome. We're going to look at total antioxidant potential using two different methods. One is using something called DPPH, and then we have another method. They're complementary methods, but they give slightly different results, so we're going to be doing both of them. And then we're going to be looking at sort of the key aroma and compounds that are produced through their fermentation by looking at these volatile and semi-volatile compounds using GCMS. In addition, we're going to be working together to write a review article on gluten-free beer. The last article that I am aware of was 2013, so it's time that we compile the work that's being done into a larger article. So we're going to have daily group meetings, and we're going to take turns presenting articles that we find on this to sort of create this review article by the end of the summer. We're also going to be able to discuss progress and issues and other ideas daily so that we can move forward and make sure that everything's working well. If this sounds exciting to you or you're interested in it, feel free to apply through the Embry site, the SCoRE program, or you can reach out to me if you have any questions, either through my email address there, dbudner@coastal.edu, or you can begin looking at from additional information, although I will admit that the website is still under construction, so there's not a lot there, but it will be continued to progress as the semester goes on or as we approach that deadline. Thank you.